team. Now, I'm indebted to our membership secretary, Nigel Wright, who has worked hard to make this virtual talk a reality. I hope you enjoy it, but please bear in mind, we're not the BBC or Channel 4. This is a first attempt, so bear with us. Ever since the branch was formed in 2003, your committee has been trying to deliver a talk on accident investigation. We have at last arranged this talk to be delivered by John McMillan, Principal Inspector of Air Accidents at the Department of Transport. A very quick look at John's background. He joined AAIB in 2005 and has been part of over 300 air accident investigations, including 80 as the investigator in charge. He is primarily responsible for the engineering aspects of investigations and has been the UK lead on several large international investigations deploying overseas. John, over to you.
Thanks, David, and I'm delighted to present tonight. I sincerely hope the tech works, and again, thanks to Nigel for all his preparation in using this advanced version of Teams and being production assistant. We'll come back to this accident in this photograph later, which is at Birmingham in 2006. So what I'd like to talk about tonight is a little bit of the background of why we investigate and our regulations, and talk about who we are, talk a little bit about the various types of investigation we do, and then I've got 3 case studies to go through: a Learjet in Mexico City, a Super Puma gearbox that happened in Aberdeen and again in Bergen, which is a heavy engineering investigation, and a 737 freighter at Birmingham, which you saw on the first slide. I'll also conclude with a few trends about where accident investigation is growing, talking about recorded data, electronic flight bags, a bit about military work that we have been doing in the past, and UAVs or UASs, depending on your preference, and the trends in that, which is a lot of work for us at the moment. First of all, why investigate? And it's really simple. It's to determine the circumstances and causes of accidents and incidents. And we're a safety organisation. We're nothing to do with the CAA. We're all about safety and preventing accidents and incidents in the future. We've got very strong powers of access and impoundment of and quarantining of evidence and forcing people to talk to us if we want them to. But all we do in having our armoury is issuing safety recommendations to prevent reoccurrence. So we haven't got any enforcement powers. We can't make any regulations. We make safety recommendations, and that is our main output. And we don't apportion blame or liability to any person. Now, this is always a little bit contentious, because if you write a report, we don't mention the airline, we don't mention the actual pilot's name. However, if you get the registration, you quite clearly, if someone's done something that's less than a good day at the office, there's an element of potential blame can be perceived, and certainly the press leap onto that. But we're very careful not to name anyone, not to name airlines, and we don't apportion blame or liability to any person. We've been going a very long time, and many other organisations have copied the accident investigation world for aircraft, marine and rail, and more recently health service in the UK. And there's also talk now of having a road accident investigation branch in the UK. But back in the late 40s, with the great explosion and rapid growth in air travel after the war, there were lots of accidents, and ICAO, bless them, came together and said, let's start investigating. And they created Annex 13 in 1951, which is our Bible. It's a fantastic bit of document. It's been revised many times. But the great thing is, pretty much every country in the world has signed up to it. So if we want to talk to people, they've all got their own separate rules around to enforce Annex 13, but we can just go to another country and we're all operating pretty much with the same regulations, rules, principles, etc., etc. And that's a great position to be in with such an international industry. The obligation is primarily on the state in which the aircraft accident occurs. So for the UK and all our overseas territories, if the accident occurs, no matter what the registration of the aircraft, it will be, and as long as it's a civil aircraft, we will investigate. Occasionally, you get situations where a state doesn't want to investigate and someone else might investigate, like the state of registration. But basically, if it's where the accident occurred, that is the first dibs on the investigation, and that's the state is obliged to investigate. Every state has its own national regulations for safety and regulation and regularity of air navigation. In the UK, we had a lot of work in the late noughties with Europe to get all our regulations across the European countries aligned in 2010 with EU 996. We've had several iterations of our UK regulations, and we've just refreshed those, but I'll be fair to the EU, they did a pretty good job with EU 996, and our little icing on the cake 2018 regulation just put a few bespoke things in place. So we were all very happy with, certainly in the UK, with EU 996. And that gives us our remit to investigate through prime legislation, to force people to talk to us, to interview witnesses, to impound evidence, and produce, as we're obliged to under Annex 13, a safety report and make recommendations. Where are we going with this next year? Well, I'm pretty sure what's going to happen is we're going to just basically merge these two sets of regulations together, and we'll operate with a UK 996 type regulation, and it'll be just business as usual. We don't really see any great change in our branch as a result of Brexit coming around the corner. This is an image of where we are. We're located in Farnborough. We're about 50 people strong. We're very, very fortunate. We've got this old ex-MOD hangar here and a slightly smaller hangar, and then we've got this our office space here and a very decent sized conference room. Sometime in the future, we may well organise, if you want to come and look around the hangar and come down, you'd be most welcome. But obviously during lockdown, it's all a bit tricky at the moment, but we can talk about that offline. But this is on the outside of Farnborough Airport. Who are we? Well, we've got 4 types of inspectors. We have operations inspectors who are basically pilots. They're all ATPL qualified. Many of them ex-military, but increasingly that's less so now. A good mix of people who fly both fixed wing and rotary wing, and most of them actually fly both. And we actually keep their currency up. So most of our pilots are flying 1-2 days a month for an airline or in the North Sea. We've got engineering inspectors. That's me. Mostly civil, but a few increasingly coming from the military. All experience in the aerospace industry. We differ from some countries. We don't take graduates. All our people have typically got 10+ years before they come to the branch. And we also encourage engineering inspectors to undertake and get a private pilot's license. We have engineering inspectors who specialise in recorded data. These are our sort of heavy duty techie people, and that's the group growth area for us at the moment. Again, very heavy on their avionics and background in data and non-volatile memory. Again, private pilot qualified. And we have currently 1 human factor inspector. We have lots of links into other places for human factor type skills, but psychology, lots of research type background, and speciality and things in pies or things like ergonomics in our armoury. That's the obligatory organisational chart. We're about 50 strong in total. We've got a chief, a deputy chief, and we've got 6 principal inspectors. This one's me here, the sort of jack of all trade with looking after comms and our engineering support, as well as quite a few internal projects for IT and what have you. We've got 2 groups of ops inspectors, pilots, 1 recorded data and 2 engineering group, and 15 very, very important and very competent admin support staff. So what is an accident? There's very precise definitions in Annex 13, and they're all mirrored in the various regulations that the countries have throughout the world. But basically, the key words here, there is an intention of flight taking place. So if an aircraft's parked on a runway, generally speaking, that's not intended to fly. We wouldn't investigate unless there were very special, interesting circumstances. There's an intention to fly, and thereafter, you need to have a fatal or a serious injury, some significant damage to the aircraft, so tyres, brakes, propellers don't really count, but significant damage to the aircraft, or the aircraft is lost or inaccessible, which in the case of MH370, for example, which I was heavily involved with a few years ago, the Malaysian airline 777, you know, if you haven't found it, that is clearly an accident by Annex 13 ICAO definitions. We didn't used to, until about the 90s, investigate serious incidents, and actually, fair play to ICAO and the EU, there's an awful lot of safety we have from things that might have been an accident but weren't quite. We very rarely do those for GA aircraft, but for where our main focus is, which is the fare-paying passenger, we're probably doing as much as serious incidents as we are accidents in terms of where we can learn some serious lessons, and I'll come back to some current things we're doing on that a bit later. So in a typical year, we get the phone rings about 1,000 times. We deal with a lot of those with no further action, very minor things, and people are just trying to be helpful. And we'd rather people phone us than not phone us. We really like to try and capture as much as possible. But about 200 times a year, we will deal with a correspondence investigation. That is generally a GA pilot has an accident by the definitions of ICAO, and we will send them a form. We'll do it by correspondence. We call it an ARF, an Air Accident Report Form, and we'll write maybe half a page, maybe 3 pages, and we'll publish those once a month in our bulletin, which is online and still a paper copy and sent to flying clubs around the UK. About 30 times a year, we will deploy. We'll send 2, 3, 4 plus people to a field. It might be a GA accident, GA fatal accident. That'll be a field deployment. Or if there's a serious incident or an accident to a passenger aircraft, we will deploy a team, and that's a much more significant investigation. It might take 9 months to complete, and again, we'll report that in our monthly bulletin, available online, and with recommendations, etc., etc. Perhaps once, twice, 3 times a year, big investigations, a formal investigation, standalone report, a yellow report. We make those reports available. They take a bit longer, and occasionally as well, if we have an urgent need to do something quickly, like we're deployed to somewhere, we want to make a recommendation very urgently, we haven't finished the investigation, we'll use a 2 or 3 page special bulletin to make a recommendation. And again, I mentioned earlier, our currency is recommendations. We make recommendations about safety to improve safety. In keeping with Annex 13, all our field investigations and our formal reports, they're sent out for consultation. So anyone, the pilot, next of kin of the pilot, if they're deceased sadly, the owner, CAA, EASA, they will have an opportunity to comment on the report, on the factual content of the report, and that's how we get feedback, make sure we've got all our ducks in a row, and that's a confidential report, draft report, before we come back, submit all the comments, and then publish it in the public domain. So it's very tight sort of secrecy and scrutiny up until that point, and then it's in the public domain, and we try and be very, very open about the safety message of what we're trying to achieve. And again, this is a safety report, so we're investigating to improve safety. We don't put things in the report that aren't really necessary, that perhaps lawyers might want for their building a case, for example. It's about the safety, and that's the bit that is really, really important to us. Comes in many forms. Air accidents. I'll put a few photographs here. Lockerbie still sort of lingers in the memory of a few people, and it was only about 10 years ago we had the wreckage in our hangar with a reconstruction of the fuselage and where the bomb happened. The top right is the Stansted Korean Air 747 that took off at night just before Christmas, and that was the last major commercial aircraft accident with fatalities in the UK. This is a helicopter accident in Norfolk that happened at night. There was nothing found wrong with the helicopter, and we do have there's about 15 or so British overseas territories of which 8 have aviation industries. That's nice work if you can get it, and it's not me there. It's a colleague in Turks and Caicos in December a few years ago. But we do deploy about once a year to our overseas territories, and it could be the Falklands, it could be Bermuda, Gibraltar, that's Turks and Caicos, Cayman Islands, Montserrat we've been to recently, British Virgin Islands, etc., etc. And we do quite a lot of training with those organisations. Interestingly, both Bermuda and the Cayman Islands have a very significant fleet of aircraft on the registration, typically 600 or 700 aircraft, and very little general aviation. So a lot of the Russian low-cost airlines are registered in Bermuda, and if there's an accident by virtue of the fact that they are a UK reg, a Bermudan reg, we occasionally, once every couple of years, find ourselves going to a major accident in Russia to support that part of the investigation as part of an international Annex 13 investigation, which has always worked very well, although it can get a bit cold. Case studies. Now, this is the first of my case studies. It's got some great photographs, which is why I chose it. This is a Learjet in Mexico City in 2008, which I was fortunate enough to participate in. The aircraft was carrying the Interior Minister, Camilo Moreno, who sadly died, along with 9 others on board and 7 people on the ground. Now, this was a fairly straightforward investigation technically, but it had, as you'll see in a minute, lots and lots of interesting parts to it. The aircraft was inbound to Mexico City. It's a very congested airspace with a sort of bowl effect that circles the traffic in. And actually, the cause of the accident was fairly straightforward. It was flying behind, it was below and close to a Mexicana 767, and it encountered its wake vortex behind it, and it rapidly departed from flight and plunged into this area here, a park on the outskirts of the financial district of Mexico City. I use this slide a lot for teaching. Colleagues there in sort of what we like to teach, a sort of classic investigator pose of hands in pockets, not touching anything, and just understanding the impact sequence, understanding putting it all together and putting it all in place. And here, just to give you a sort of a good flavour of the sort of things we look at. Yes, there's an FBI Go team in the background doing a site survey, and yes, there's a Mexican investigator here, but you know, our 2 guys here are piecing it all together, and it's not just the really obvious physical evidence, it's the lack of evidence as well. So in this case here, you can see this this Volkswagen has a winglet, and I'll show another photograph in a minute, embedded in its door here. There's a large amount of damage to this tree here, and various small amounts of damage to the various twigs and branches. But clearly here, this lamppost, this post hasn't been damaged, and nor has this fairly flimsy cable. You can see the huge fireball in the background where all the wreckage ended up. So, you know, we're sitting there thinking, hang on a minute, it's damage on, you know, where's this all going? How did the aircraft strike the ground? And if you piece it together, it's a bit crude this, but you can see here the winglet in this VW. You can see here, and we found a piece of wing with matched up this piece of damage to the tree, and the fuselage just hasn't touched these 2 pieces here. So we were very, and actually in this case, the black box didn't work. So, you know, back in sort of 2000 era, 2010, we were getting perhaps 1 in 10, 2 in 10 black boxes weren't actually giving any data. It's pretty much 100% these days with solid state, but with some of the older aircraft, it was quite it wasn't, you know, that reliable. So we didn't have the recorded data, and so the physical evidence here was super important. And we were doing all this obviously with the press interest. We were invited there not because, for no other reason, the fact that it was an American aircraft, the Learjet, had American engines, a Mexican registration, and a Mexican crew. But the Mexicans were very concerned about impartiality, and it was a bit tense with USA at the time, probably more so now, I guess, but at the time, and therefore we were invited as an additional group of people there, and they made quite a bit of play of us being there. And we had to do all this. This was the press who were there at 9 o'clock on a Saturday morning, broadcasting to the world, and they were doing an interview with the Minister of Transport, and there was, we were just doing our job in the background, which was kind of slightly high pressure, but interesting to say the least. And as you can see here, absolutely no shortage of manpower in Mexico City for this security exercise, and also for the clear up, which was incredibly swift once we'd done what we needed to do. Moving on to a heavy engineering investigation. This happened, there's two accidents here which are basically the same accident. In 2009, in the North Sea, this Super Puma, an L2, crashed into the sea about 11 miles off the coast. Over the last, I think, 40 years, we probably had about 20 or 25 big North Sea accidents, many of them fatal. Thank goodness there have been a lot fewer recently, but there have been two significant events in the last few years, the last 10 years or so, and this was the first of them. And we got involved with this. Obviously, it's a G-Reg. It was in the UK territorial. It was in the UK, occurred in the UK, and so we investigated. That's the sea recovery operation in a sort of summary. Very, very expensive. This was a photograph taken. I love this photograph. It's got a photograph of a fish next to the black box, but and if you didn't know, black boxes are generally orange. That's the black box, modern data recorder at 95 meters depth, and hundreds of, not too far shy of £1 million worth of recovery operation for sort of 10 days worth of very expensive saturation divers and sea recovery vehicles, with a couple of our guys on board to get the wreckage. And actually, the recovery operation itself was perhaps only, I think, less than 24 hours, but we actually were bringing up wreckage, reasonably good seabed, fairly clear, but we didn't know what we were looking for. We didn't know if it was an engine fire. We didn't know what the problem was, and it later transpired to be a gearbox problem, fatigue in the gearbox, which I'll come to in a minute. And we didn't actually get the key bit of metal about the size of my hand, which had the actual fatigue in. We had the other side of the fatigue failure, and that was always a real problem with that investigation. So, but we made lots of recommendations, and as EASA were reviewing a lot of the work that was being done, it did take a long time for Eurocopter, now Airbus helicopters, to actually start to actually take on board a lot of the work from the recommendations from the 2009 accident. And then I was at the top of our Go team list in April 2016, when a copycat accident happened to a 225, basically the same helicopter but slightly uprated Super Puma, a bit more power going through the transmission. This aircraft was inbound to Bergen. I hope that shows up, but if you can't see that, it was basically levelling off at about 2,000 feet, very steady, inbound to Bergen, and the main rotor head detached. In the previous incident, there was about 1 minute's worth of gearbox transmission noise, and the pilots were wondering what to do about it, and they said, well, we think we can get back home with this. There was nothing in the manual that said don't ditch in the sea, and obviously a very brave person would ditch in the sea to do that. On this occasion, no warning whatsoever. The main rotor head detached, and from 2,000 feet, the helicopter plunged into the a little island. It plunged into this island here, with the wreckage falling into the sea. Fortunately, the tide in Norway is only about half a metre, and so we had a pretty good recovery operation of the bits that we wanted, and we could keep going back, and we knew where they all were. The main rotor, a bit like a sort of sycamore or a child's toy rotor head, there's some video footage of it, just drifted down onto land, which looked like that, pretty much intact, and pretty similar operation, but a lot swifter and fortunately cheaper operation in Norway to recover the wreckage. Now, this is going to be the difficult bit, and I hope I'll bear with me, and I hope I'll go at the right speed to explain this. There's two engines on this helicopter, both going at about 22,000 revs per minute. It takes it through a bevel gear here to change direction. And then there's the bit missing here, and that's the clue, we'll come to that in a minute, is a epicyclic gearbox, which then, we'll come back to that, which then reduces the revs per minute and increases the torque, and it reduces the revs per minute from about 22,000 to about 265 revs per minute for the main rotor head here. Now, that's the fact it's all missing is kind of a big clue here when we reconstructed it in Norway in a hangar there. If we look from below this point here, this is what an epicyclic or sun and planet gearbox looks like. It's got two stages on top of each other. It's like a very big Sturmey Archer bicycle gearbox, if you've ever taken one of those to pieces. And basically, it's got a sun gear, which isn't here at the moment, meshing on, in this case, 8 planet gears, and those also mesh on an outer ring gear, an absolute work of art. One of the most important parts of the helicopter is the gearbox. This is a particularly clever, beautiful design, very light for what it's doing, and very compact. Each of these gear wheels here looks like this, and each of these gear wheels clearly needs to have a bearing in the middle. And you can see these sort of shiny objects here about the size of my thumbnail. There are 24 roller bearings inside each of these gear wheels, 28, sorry, and they roll on an inner race in the middle and an outer race. They roll on the inside on what is actually almost a spherical, inside of sphere surface inside this cylindrical gear. And this gear is about 7 inches, like a sort of small cake size gear wheel in high spec steel. Now, we knew from the first accident that this had failed due to fatigue, but we only had one half of it, which was the wrong half of it. We wanted the half of it which actually had the initiation of the actual fatigue, and we didn't have that. On this Norwegian investigation, if I show the next slide, we had the bit that had the initiation. So that is, after all that wreckage recovery, we're talking of something that's basically, smaller than my hand, basically, and that's a quadrant of one of those gear wheels there. And this bit here, this little peanut feature, and you probably won't, I'll show you in a minute, there's some little divots, little spalls coming our way here. And you can see here it's like a sort of spherical internal face, and the gear wheels, those bearings, those roller bearings, roll along here and along here in 2 fairly well defined tracks on this smooth surface. If we look at this face here, that's what it looks like. I spent a lot of time over at the other side of the runway at the labs at QinetiQ, working with the material scientists there. You've got this peanut feature here, which is the start of the failure when it goes through the actual metal. That's the gear tooth there. You can see on the bottom of the gear tooth is here, and this whole fatigue is spread out, causing the whole gear tooth to fail. Once that fails, the gear wheel opens up, it jams the gearbox, and the whole there's so much energy involved. The support structure cannot support the actual jamming of the actual main rotor head. The main rotor head detaches, and that's the impact sequence. So what I'm going to look at here is what caused it to actually fail in the build-up to this through fracture, through surface, through metal failure. And that's the actual, I don't know, peanut feature. That's the actual fatigue surface we looked at. And this is the line where the actual bearings actually roll. And this is what we found, with lots of cleaning up and very, very painstaking work to remove debris and corrosion from even just a few hours in the sea. We find these little spalls, 1, spall 2, spall 3, they're 2 or 3 centimetre wide divots that have opened up and generated material. Now, normally what happens with these sort of failures, you get material being generated like spalls, it's fairly natural. You detect it with a mag plug and it tells you something's wrong and you pull the gearbox. But in this case here, they had 3 tiny little bits that didn't show up on a mag plug, might have even failed on that flight. And this is an enlarged version of it, you can see them here. And if I take a section through here, we then did some fantastic work with QinetiQ and Southampton University to do an X-ray. And that's that peanut feature I talked about. This is one of the spalls, the big spall, that's a little spall. And what we could see from here is all sorts of tiny cracks underneath the surface where the rolling contact fatigue was doing its stuff and causing the pain. And lots of things were generating, but this hadn't actually pulled away yet. This bit had, and but on this occasion, the fatigue went all the way through the surface and caused a failure. So that was probably about a year's worth of metallurgy, several, hundreds of thousands of pounds worth of work, lots of painstaking work in the lab, and the fleet was grounded in the North Sea of this helicopter for I think it was about 9 months in the end. So a lot of pressure. We want our helicopters back. A lot of legal work in the background. People saying, we want access to this. Our helicopters don't work. Lots of legal cases in the background. So the pressure was really on in that case, and that was very rewarding, very challenging, but also but quite a testing investigation. Here's the third case I'd like to talk about. This was in 2006. It's a 737 freighter at Birmingham International. That's the photograph I showed at the beginning. I was woken up to bed very early in the morning and told to get to Birmingham as fast as I could. And this is what I found. I also was made aware very early on that England football were playing against Trinidad and Tobago in the World Cup in Germany that day, and there was about 4 or 5 aircraft desperate to take off full of England supporters. We want our airport back. No pressure there. And obviously the first thing you notice with this photograph is where is the right main gear leg. And I went out with the airport ops people. We drove there to the runway. We found a metallic mark emanating from the bottom of the right nacelle, about 1 kilometre long, but we could not find the gear leg. What had happened? And then as the morning evolved, we realised actually it'd been very, very foggy overnight. This aircraft had been inbound to East Midlands, and as the fog was clearing at about the time I arrived at Birmingham, we got reports of a Ryanair flight about to take off, saying I can see a gear leg to the side of the runway in the sterile area. What's going on? And as it turned out, this aircraft, the 737 I showed you, had actually tried to land at East Midlands, which is a massive freight terminal, in the middle of the night or in the early hours, and it had missed the centre line by about 90 metres. Sorry, wrong way. And these are the ground marks. We've got these marks by the main gear, the nose gear, then the nacelle, the outboard flap track, which you can match up the marks here. So I was basically matching up my damage on the aircraft with the damage that my colleague was working on at East Midlands, and then the right wingtip. So this is probably the closest we've come to a fixed wing commercial air transport accident in the time I've been there. Very lucky to be alive, very lucky not to cartwheel down the runway. And there's the right main gear leg assembly as found. So what had happened? If I can boil down a lot of work from my pilot colleagues. This was really much a limitation of human performance, a human factors type investigation. Very late on in this Cat3 approach in the fog, they received an inappropriate RT message just about company business. They didn't want to hear this. They were really concentrating hard. They were working hard, and as a result of that message, the commander inadvertently disconnected the autopilot, and that's the real crux of this. They didn't decide to go around. They lost situational awareness, which I think you can probably see, and we identified several issues for training, primarily around the lack of go-around call, which was basically the main issue here. Other issues we look at, we're always looking to try and find any angle we can for safety. Here you can see the gear legs come away. There's a big black tyre mark up the side of the fuselage. He's been very lucky not to have the tailplane ripped off or severely damaged by the right gear leg as it struck, as it came off. And what I was looking at here as well was some of the survivability issues. Now, in this case, fair play to Boeing. They have a design philosophy that says, let's have structural fuses, weak points in this case, where the landing gear attach, and the landing gear, where they have excessive loads, well above any heavy landing loads, the gear will just detach and break away, which it did. They lost some hydraulics, but primarily the most important thing here was the wing fuel tanks weren't ruptured, and the actual aircraft was able to fly relatively normally, albeit with a slightly damaged and fixed flap configuration. And they also got the same sort of fuses on nacelles, which were intact in this case, but I'm fairly confident that they would have done their job if they had been asked to do so. So, I did quite a lot of work on the actual structural integrity of that, and just an interesting photograph really. That's the bottom of the nacelle with all the damage, and that's what 1 kilometre, at 130 odd knots looks like to the bottom of the nacelle, and that's the grass that came out that had come from Nottingham. We get quite involved with recovery side of things. I'll just go through these fairly quickly, but if someone's got a blocked airport and they want people to, losing money, suddenly all sorts of things appear very, very quickly to help. I wasn't too fussed about the airport being closed, but we are able to, put sandbags in the front to prop it up, get the balance right, and we had a tractor tailing. We had a flatbed from under the cell on one side, and a tractor put on the side, and we were able to move it to an appropriate part of the runway in the early afternoon. So I think Birmingham were fairly happy with keeping it with the result at the end of the day. So to finish, I've got a few slides on recent trends at AAIB, and certainly one trend I have to mention is recorded data. So historically, our group, they were called Flight Data Recorder Group, and they're now the Recorded Data Group, because there's so much information out there in all sorts of formats, not just black boxes. We've got mobile phones, we've got iPads, all sorts of apps that pilots use, radar, and huge amounts of CCTV. There's just so much stuff out there. We've got cockpit cameras now. So many actual avionics boxes have non-volatile memory, and often it's more comprehensive than the actual data recorders. Typical data recorders now, we're looking at about 3,000 parameters, 8 times a second, huge amounts of data. Some aircraft have 2, one at the front and the back, and duplicated data. And even the acquisition units can have more information than the actual data record itself. Go back, 20, 30 years, and we still see occasionally that these aircraft, older aircraft, some of them have like 8 parameters, not solid state, mag table, all sorts of things. So huge advantages there, and our guys, that's a huge growth area for us. And fusing the data from a flight data recorder and a cockpit camera or a GoPro is what they get up to these days. I'll show you a few CCTV photographs here. They're getting much better, rather than the Learjet I showed earlier that had about 4 snapshots about 5 or 6 seconds apart, very poor. Here, you know, we can get all sorts of information about an impact sequence from that sort of CCTV. And increasingly with air shows and aerobatics events, we get really high resolution CCTV. Like for example here, I won't go into too much detail, but we can actually, you know, really get so much information about what happened in an impact sequence or in the build-up to impact sequence from CCTV. I mentioned earlier serious incidents, and I think we're doing a lot of work at the moment on is takeoffs from runways, so closed runways and taxiways, or increasingly major failures to achieve predicted performance during takeoff. And this is hugely of interest at the moment. So this happened in 2016, 17, I think it was. This is Belfast. The picture here isn't the incident, but it just gives an indication of what's going on here. All we have here is a missing runway light. On this occasion in Belfast, a 737, people going off on holiday to Greece. They had a late nose wheel change, and during the wait, the crew decided to reprogram the electronic flight bag to derate the takeoff to preserve engine life. And so rather than entering 16 degrees, which was the OAT at the time, they put in minus 52 degrees, which was the cruise, the forecast temperature in cruise. And that resulted in what was a moderate derate suddenly be an aircraft that was taking off with only 60% of the thrust available. So it took the whole runway to take off, took out a runway light, and at about 4 kilometers from the runway, the end of the runway, they were only at a few hundred feet when they realized they need to press the toga button and full thrust, and away they go. So we actually made it, that's a formal report. 30, 40 years ago, there wouldn't have been a formal report for us, but there's huge amounts of safety in there, looking into the psychology behind programming, the interface with the actual electronic flight bag and with the computer involved, and the software refreshes of that. Back in the 70s and 80s, and even in my time in the early noughties, we were doing a lot of work to support RAF accidents, probably 5 or 6 in the noughties, and certainly in the 70s to 80s to 90s, 10 plus accidents a year for the RAF. They didn't have an investigation branch per se, and we'd always get involved to go and help them with their work. And they were fascinating cases to look at. As I said there, I've been involved in 4 in the early noughties, but now with Haddon Cave report after the 2006 Nimrod accident, the Haddon Cave report of 2009, they set up the MIL AAIB for aviation, and that subsequently has morphed into Defence AAIB to look at all sorts of defence accidents for marine, land vehicles, etc., etc. And they were the MIL AAIB, and a large chunk of the DAIB were co-located with us at Farmer for many years, and they've now moved on to a bigger headquarter at Boscombe, where they're set up, and we still do some work with them. We invite them to some of our deployments for training, but they've just outgrown their link with us, which was kind of the plan, I guess. But in terms of our side of things, they've got a dedicated team. We're not deploying to military work anymore. Only, well, very minor stuff, but it's almost nothing really. And my final issue is UAVs or drones or UASs. Now, this actually is a UAS, an unmanned air system. It looks like there's a person in it. It's actually an air lauder airspeeder, an accident that happened in 2019, and they made a mock-up of what would be a manned vehicle, but made it unmanned to demonstrate it. And it's I think it's a 2/3 or 3/4 size model of it, but it demonstrates, I think, very well the issues that we're seeing with a lot of UASs that are emerging. A lot of them are getting much bigger, and a lot of the issues coming out of them are very similar. This particular vehicle, it took off. It was at the festival's speed at Goodwood, and then fairly soon after takeoff, it lost control with its ground station, and just sorry, I should say 5,000 feet altitude, not 500. My apologies. And that's a fantastic photograph it took, where it went almost straight up in the air over into controlled airspace on that day, and then it plunged to the ground about a kilometre from actually where it took off. A lot of people were at the festival. Luckily, it went in the right direction, away from the crowd line, but it was quite close to a housing estate. Quite a few issues. Now, this report's actually out at consultation now, so I can't give you too much of the flavour because we haven't actually fully agreed the report. But it needs to say the kill switch did not work, and there's an awful lot of work we're doing, and we're engaging very heavily with the CAA in the UK about some of the design issues and what are the standards for designing and building UASs, because they're just not the same standard in many areas as you know, passenger transport aircraft as we know it. So that is it. And David, any questions you would like to ask?
John, that was absolutely fascinating. Thank you very much. Can I start the ball rolling? I guess that most of your recommendations centre around engineering requiring re-engineering, and perhaps processes and procedures requiring retraining. Are all your recommendations taken up?
Historically, we made a recommendation, and if you look back at some of our recommendations from 30 years ago, we just didn't monitor them, and now we are obliged to monitor and we assess them. So we make a recommendation. The person we make a recommendation to, the addressee, has 90 days and they're obliged to reply, and certainly within Europe they are obliged to do that under law. And then we have 60 days to assess the intent of their recommendation, and we also will have further monitoring activities saying, you know, we'll assess them and say that's partially adequate, still open, and we may say, we'll have an update please in 6 months or a year's time, or that sort of thing. So I can never say, you know, we've got no power to enforce them. And I think, you know, we're very careful not to, in our recommendations, when we make recommendations, we don't solutionize. We don't say design it this way. We say review the design of to ensure that this doesn't occur. So we don't solutionize, and it's obviously the job of normally the CAA or the ARSA to actually, you know, to enforce that downstream. And normally we'd say, even if say it was, let's say it was an Airbus or a Boeing product that we had an issue with, we thought could be better. We would generally say it is recommended that EASA or the FAA review this in conjunction with, to actually give some clout to it as well. So I can't say we're 100% successful in that sense, but increasingly the burden of airworthiness falls on the actual manufacturer and to an extent the operator, because if they don't get something right, then if something reoccurs, like we've seen with the 737. Then MCAS issues, then it's a huge penalty for the actual manufacturers. So it's a slightly woolly answer to your question. It's a very good question, and that's in some ways the frustrating part, that we can't enforce it. But in general, I think we're a pretty good success rate.
Thanks very much. The questions are rolling in now. One at the top of the list is from Josh, who says, to what extent do diversions between East and West still hinder international cooperation on safety investigations?
I'm not sure it's a particularly big issue at the moment. We've whilst we have a few issues of getting into Russia if we have to go to Russia, when we work with MAC in Russia, our counterparts, and we have, you know, technical forum now with for data recorders and material investigation work for engineering. You know, working, you know, some of these Eastern countries are slightly embarrassed they can't do more. They very much want to embrace the Annex 13 ethos. So I'm not seeing. I don't think I've really seen much of that at all. I mean, it's more localized politics in some countries who have an aversion for openness. There's still many countries in the world who whilst they will sign up to ICAO and Annex 13, you try and find how many reports they published. You wonder how open they are with their work, and their investigators at our sort of my sort of level I generally really want to do the right thing. It's the layers above that which sometimes prevents the actual output into the public domain.
Thanks, John. We have a question from Geraldine. Were you involved with the Red Arrows accidents?
No. We have, I can think of several colleagues who went to, Scampton, and there was an ejection seat, and there was a training incident in Cyprus, and there was one in Hampshire that colleagues went to, but not personally. I've been to a Hawk accident at Mona, which luckily wasn't fatal, but no, I wasn't.
Right, next question is from Bill. How do you see air props or collisions with UASs going?
Yes, excellent question. Yeah, I mean, the issue is engines particularly are designed to withstand a bird and very specific requirements for that, for bird ingestion. How well are they designed to withstand a lump of UAV or UAS? Not particularly well. It's so difficult as well. I mean, and air props, we get, it's mostly the air props board who deal with them. But how do I see it going? I mean, it's the regulation is getting much tighter. The CAA know it, but there are just so many UASs out there flying, and it's probably more. I'm personally more concerned about the malicious type of event where you might need 2 or 3 or do something deliberate. Because generally speaking, I don't think one will bring down a passenger aircraft. That it's got 2 engines and it's got enough redundancy in it. So I'm more concerned if they were being used maliciously in some way to have like a swarm of them or something like that, or a really big UAS, and that's what I think would be starting the problem. So yeah, I mean it's just a risk that's being managed. Yeah, like, again, it's like I think the most likely event we're going to get is still a terrorist event rather than actually a genuine accident, which is generally what for the Western world is the case at the moment. Not a great answer, I'm afraid, but that's an honest answer.
Another question from John this time. If we're not part of EASA from next year, is there any impact for investigation, or is it irrelevant as it conforms to ICAO Annex 13? And it's a 2-part question, do you ever get resistance to releasing contact within reports? Are the aerospace aspects of the NTSB on the most wanted list, similar to what you would generate?
Right. 3 questions there, I guess. Right, EASA. A lot of the really active players in Europe are surprisingly Iceland and Norway, who aren't in Europe. I do not see in the community, and we're one of the biggest players in Europe, along with the French. The French have grown massively because of Airbus. I can't see us not being still a major player in Europe, and the Annex 13. We may get some you can't come to the party from Brussels type of debate, I guess. Who knows? But in terms of the accident investigation community amongst the countries, I see very little difference in that. And Annex 13 has, the same way it works when we go to Canada or Australia or the USA, I see no issues at all there, and I can't see any great change there. The second question, remind me what the second question was?
Let me go back. Do you ever get resistance to releasing contact within reports?
Yes. I mean, we put the right amount of information in, we like to think. If we put a transcript of a cockpit voice recording, we put just the right amount of information in to describe what the event was and no more. So resistance, I mean, I guess there's 2 sides to that. Some people might want it not to be in, and some people want it to be in. I think the Norwegian report, was that I was heavily involved with, was right up there in putting, it's in the same those 2 helicopter accidents, the Norwegian report and our report. I'm sure the people who have priorities to the shareholders don't want those reports published because they're putting in the public domain the fact. But we represent there's a conflict there. We represent the fare-paying passenger for aviation safety, and that's our job. So yes, we do get resistance. And there was a third question there as well, wasn't it, towards the end?
Yeah, it says, are the aerospace aspects of the NTSB most wanted list similar to what you would generate?
Yes, we don't have one. Maybe we should have one. But yes, I mean we pretty much wouldn't disagree with those. I mean the NTSB have got huge fleets of Boeing aircraft to manage and a much bigger internal aerospace industry. So we do more work than they would ever do on general aviation. We've got quite a lot of general aviation in the country, general aviation, and we see it as fantastic. We're obliged to investigate. We do it in more detail than most other countries, but it's fantastic training for and background for for the big stuff as well. So and hopefully the flavour I showed there of some of the ground mark type work we do, that has read across into the general aviation world. So yeah, it's very, we don't have that list, but it's hard not to agree with them.
Okay, next question is from Thomas. Who's at the top. What are your opinions on TV programs such as Aircraft Investigation? Do you think they are accurate enough?
Personally, they tend to be, a 5-minute program shoehorned into an hour, in my personal opinion. They bring in to get good TV, I guess they want, some human element of what's going on in the cockpit and the stress and what have you. And generally, we're much more focused on, hard facts of the engineering and going right into the detail. And for example, that Norwegian helicopter accident, just if you were to watch me and some other people, spending time in the labs talking about, should we cut this piece of metal now or later, and how are we going to cut it? That's not good TV. So it's not a particularly accurate reflection, I don't think. It's not wrong, but in terms of the hours I spend doing my job, it's not a very, in terms of the balance of how long I spend on certain things, that piece of it is I guess, distorted. Okay,
next question is from Oliver. Do you foresee changes in failure modes and frequencies with the coming of electrical aircraft revolution?
Is it coming? I don't know. I mean, yes, and things getting more, well, for sure, so many parts of the aircraft are getting more electric. And are we getting, yes, we're getting, batteries, we are getting different sort of failure modes, yes. And they are getting more complicated. More complicated for us. And I think also more complicated for the regulators like EASA and the FAA, that they will struggle, and you could argue they struggled with the 737 MCAS system to actually, the regulators and arguably possibly the investigators as well, to fully understand what is a very complicated system. So just system complexity in general, of which electrification is a major part.
Okay, thanks. The next question has risen right to the top with 4 votes. Jordan has asked, what are your thoughts on MH370 and how can a commercial aircraft just disappear in the 21st century?
Maybe I should have said what I said earlier on. Right, I am the actual UK lead for MH370 and spent a lot of time in Malaysia. How can that disappear? Well, it just can. It's aircraft over the oceans just are not monitored. They are, there's radio transmissions, but they're not on by and large not on any radar. And if they aren't communicating for whatever reason, and it does look very much like it's a malicious act in that case, then it will disappear. Yeah, I mean it's as simple as that. The facts are there. I'm not that surprised. And I know, but most people, if you sit in a quiet moment and over a drink and say they're flabbergasted when all aircraft aren't totally monitored all the time, all over the world. They're monitored, with SATCOM and what have you, but they're not, sitting there being looked at on radar screens by and large over the ocean.
Okay, next question is from Steph. How many women are on the investigation team currently?
Right, how have we got? So of our inspectors, if you're talking about inspectors, we have, I think of our pilots, I think, is it 4 or 5 out of 10, and our engineers 1 out of 11. So what's that? That's about that could be 6 out of 25. Well, is that 25% maybe?
That's
Not
great.
enough. Not enough.
We're now at 8 o'clock, so you've been going for an hour. Are you happy to continue with a few more questions?
Yeah, if you want to, yeah.
They're rolling in. There's one here from Ubad Rasa, if I've got that pronounced correctly. Can't we build a system where there is no blast when the plane crashes? Rather, it should be broken or disabled so that it does not catch fire and people can survive to some extent and be safe from burns.
Yeah, I mean, is that general aviation or passenger transport? I mean, for a fire, you need the classic triangle of fuel, an ignition source, and oxygen. I would say with general aviation aircraft, it's probably only 30% have a fire when they crash. Yeah, a major crash. Passenger transport aircraft, a lot do. It's just fuel rupturing. They generally do if there's not a lot of fuel around. But Mike at Heathrow in whenever that was 2009 didn't, and an awful lot of aircraft do crash. The Air France crash at Toronto in when it was 2005 or 6. That went off the end of the runway. Yes, it did burst into flames, but there were no fatalities there. That landed in very bad weather. I think it's a huge additional effort. I mean, the regulators are sitting there, and take the Manchester disaster in the 80s. We made recommendations about floor lightings and smoke hoods, and the regulators, the CA et al., took the information away and said, actually, do you know what? In terms of the costs involved and any unintended consequences, yes, floor lighting is a really good idea. It's cheap, it's effective, it's not going to get tampered with. Smoke hoods, expensive, not quite, it needs to be used correctly, and potentially they could be, there's an overhead there of maintaining them. Can they be and will they be misused in any way? So and that was not taken up, and that may be that probably was the right answer back then. So again, I haven't got the detailed information in front of me, but that type of argument would have been done for that if this is the case. What do you need to do to make the aircraft break up in that way? How much additional cost, maintenance burden are you going to make more complexity to a system that probably doesn't need it for the number of lives you might save? So there's those very complicated sums that people in the regulation world have to do.
Thanks. Next question is from Martin. How are inspectors prepared or counselled for the trauma of the sight and smell of human injuries, remains at accident sites? Rather gory question.
No, that's a really good question. Yeah, so we're all screened at interview stage, psychological assessments. We have every member of staff, including the admin staff, have a psychological assessment each year for all sorts of things about stress, trauma, etc., etc. Anyone who actually, and it's almost the mentality we've got now, which is I think fantastic. It's become much more prevalent in the last 3 or 4 years, of a football team or a sports team. If you've got an injury, you're letting the side down if you play through an injury. And actually, if your mental health's not up to it, flag it up, go and get some counselling, etc., etc. It's gone on the days where we go to an accident site, we all go back from the day, we lock ourselves in the pub and have a beer, whatever, and talk about it, but don't talk to our other halves. That we've moved on from that, and so I can think of colleagues who, and sometimes it's not just what the sights and the smells, the question posed, but also talking to people who might have actually seen something, or talking to a pilot who may feel as a result of his or her actions that someone has lost their life. Those can be probably more upsetting than some of the things that we're talking about in the question. So we take it very seriously, and we've just got a program at the moment which involves training several members of our staff to be psychological first aiders, to actually help people dynamically in the field, if you like, with the work we do. So we take that very seriously.
Thanks. Next question is from Chris Brem. What are the biggest engineering improvements that you've seen emerge from your time as inspector?
I think just build quality in general, and you know, gone are the days where you hear these amusing stories of Nimrods or MRA4 being you know, wings being put you know, be re-winged, and actually the inaccuracies and the build quality is so variable about how, you know, what the root chord is to bolt the wing. And if you take Mike the 777 at Heathrow, the fact that both engines actually rolled back and throttled back almost simultaneously, the build quality must be so fantastically good to actually have that situation, that you know, and even some of the engineering aspects from the gearboxes of the Super Puma, comparing those to an 80s Puma, whatever, the quality is so much better. But, you know, surface quality, build quality, material spec. When you do the metallurgy, it's you don't really see it, but it does. You know, it's all there, I think.
Okay, next question is from Andrew C. How important is ADS-B and global monitoring by satellite going to be investigating accidents and serious incidents?
Yes, very. I mean, it is being used over in Canada and probably more places. I'm a little bit out of touch the last year or so. It's probably come on since then. The big question is, at what point do we encrypt and send almost black box data in packaged information, so it's not on the aircraft? I mean, if we probably will be investigating space accidents, AAIB, at some point when things start moving in that direction. And one thing you get with, for example, with space accidents is you get a bucket load of data, but it's not on the actual vehicle itself. It's all real-time telemetry back to the actual control center. So that's where it ultimately will be heading, but it will take time. You've got huge fleets of aircraft there with black boxes. It's not going to be happening in the next year or two, but it will be coming.
That's great. Last question is from Jordan. What do you think about the new Garmin emergency autoland system, and do you think this will be seen in commercial aviation?
I'll have to pass on that one. I'm not familiar with that system, but I guess it's coming in the way that cars are developing that direction. But I'll decline that question just because I don't know enough specifics about that particular system, I'm afraid. Apologies.
Okay, well, that brings us to the end of this, our first virtual talk. John, thank you so much for giving us your precious time, and we now know enough about air investigations to become dangerous, I think. We have a small gift to give you, which will come in the post.
Okay, thank you. Very much appreciated.
Engraved whiskey tumbler, which I hope doesn't meet with any accidents. But thank you again, and thank you, Nigel, for producing this programme, which I think, from my point of view, has come out as a great success. Thank you.
Great. Thank you very much indeed. Pleasure.